Hi there, geometry students. This is Ms. Hefty here. We are in section 4.4.4.5 and we're doing part 3 on our triangle congruencies. In part 2 we talked about proofs, and on part 3 we're also focusing on proofs. In part 2 we were focusing on triangles that maybe weren't overlapping. So I have a triangle on the left and the triangle on the right. And I also was doing things like where they shared a side, and I have a triangle on the left and I have a triangle on the right. Now we're going to have more complicated ones where we need to determine, okay, which triangle am I going to use? My triangles are going to be overlapping. So let's take a look at our first example. Do you see in that diagram, in that picture, that there are many triangles? You have the triangle small triangle on the left, small triangle on the right. You have the larger one that's doing the overlapping, the larger one on the right that's doing the overlapping, and then you also have this smaller one. In this example, they are telling us which triangles we're going to use, which is nice. Sometimes we're going to need to decide that on our own. See at the proof it says triangle ABD, so ABD. So I'm using this large one, and I'm proving it's congruent to DCA. All right, so I'm using those two larger ones that are overlapping. I'm given angle 1, congruent to angle 2, and B, congruent to C. So I'm going to mark those. I'm also going to write those down. In my proof, down at the bottom in number 3, I'm showing that the two triangles are congruent. So I only have one step to do here. All right, so now I have two angles marked. So I have an angle and an angle, so I'm going to need a side. I'm not going to have AAA, that is not a triangle congruency test. Do you see here, this red line is AD. And this green line here is also called AD. That's a shared side. And this one I had a shared side right here. So I'm going to write AD, congruent to AD. I'm going to use the reflexive property. And now, mark that. I've got two angles and a side. My side is not between my two angles. So angle, side, it's not contained. It is not angle, side, angle. It's not between the two angles. This is incorrect. All right, let's take a look at our next example. We're given BD to bisect angle ABC. So here's ABC. So 3 and 4 are going to be equal. And then DC, 1 and 2 are going to be equal, because bisect means to cut into two equal pieces. Now I need to decide what triangles I'm going to use. Do you see here, people? You have the triangle on the left, you have the triangle on the right, you have the triangle on the top, you've got the triangle on the bottom, and then you've got overlapping triangles. So I need to figure out which triangles I'm going to use. So I'm going to look at my proof here. Here's side AB, and here's side DC. I need to prove those two are congruent. So I need to use triangles that have my givens, and I need to use the triangles that have my proof in it. So do you see here, I'm using this one because I have this angle and I have this angle. So I'm going to use the one on the bottom and I'm going to use the one on the top. That's what I'm going to do. All right, so let's start. Go ahead and write your given down. I'm going to go all the way down to number 5 and I'm going to write my proof. If I'm going to talk about parts of triangles congruent, then I first need to show that the triangles are congruent so that I can say the parts of the triangle are congruent. So in number 4, I am going to go triangle congruent to triangle. Okay, now let's go back up to the top. I marked 3 and 4 already, but I have not had 3 and 4 written in my proof anywhere. I have bisect, but I did not write angle 3 congruent to angle 4. So that's what I need to do now. And how come I marked those two? Because of bisect. So I'm going to write definition of bisect here. I also marked 1 and 2 for the same reason, so I'm going to write it on the same line. All right, now I have two angles marked congruent, and I do have them in my proof that I've written them as congruent, so I need a third thing to be congruent, and that's going to be my third step. Do you see here again what's happening? I have overlapping triangles, and so they share DC and DC. So I'm going to go DC congruent to DC, and that's the reflexive property again. And now I have to go ahead and name my triangles. I'm going to start with A. I'm going to go over to B and then down to D. And then I need to start at C, go over to D, and then up to B. And my reason is, here's my shared side. Again, I have two angles and a side. The side is not contained or between the two angles, so it's angle, angle, side. Once again, angle, side, angle. The side has to be directly between the two angles. Here are my angles that are marked. This is the side that's directly between them. This is not the triangle congruency postulate you're using. All right, so now if you have triangles congruent, then the parts, the sides are parts, so you're going to use corresponding parts of congruent triangles are congruent. All right, so a little more challenging proofs this time around. You guys have a great night, and I'll see you in class tomorrow.